time, and I'm delighted to be with you tonight and provide the basic SKYWARN spotter training. When you look at this title slide, if you look across the series of pictures, you see a hurricane striking North Carolina, and the next one is a winter weather storm. We had an ice storm back in 2002, which left most of the Triangle and Triad with anywhere from a quarter to a half inch of ice, and there were numerous power outages that lasted up to a week or more. And then going to the next picture, this house is sitting a little bit askew from its normal position. This was a house that was suffered the fate of one of the tornadoes that came through Lee County back on April 16th, 2011. And then down in the eastern part of our coverage area, you see a flood, and you see the rooftop just above the floodwaters, and this is from one of the tropical storms that passed through North Carolina. So we definitely get our share of severe weather. Next slide, please. Central Carolina SKYWARN serves the Raleigh National Weather Service, and the Weather Service can be found on Centennial Campus, in CSU Centennial Campus in Raleigh. It never shuts down. They have 24 employees, 17 of which are meteorologists, and there are, in normal non-COVID times, there are 3 meteorologists there around the clock. In COVID times, it was 2 and 1 working from home, but my understanding is they're getting back to normal. So they're open 24 hours a day, 365 days a year, and the Raleigh National Weather Service is one of 122 forecast offices which serve the continental United States, plus Alaska, Hawaii, and Puerto Rico. Next slide. Okay, North Carolina itself is served by 7 different forecast offices, and you can see the coding by color, which counties are served by which office. Central Carolina SKYWARN is part of the Raleigh National Weather Service SKYWARN program, and the Raleigh National Weather Service counties are colored in blue. Raleigh has 31 counties in their county warning area. Next slide. Okay, so what does the National Weather Service actually do? Well, their #1 mission is to issue hazardous weather warnings to protect life and property. And we see the warnings all the time come out either on the radio or across a little banner on the TV. Sometimes we get the WEA warnings on our telephones. All of these are issued by the Raleigh National Weather Service or other weather service offices, and they are picked up by media and broadcast to the public. Not only do they issue the warnings, but they also prepare weather forecasts for daily use. You can get the forecast for 7 days. They provide other weather radar and satellite information. When watches are issued, like a severe thunderstorm watch or a tornado watch, they're issued out of Norman, Oklahoma, the Storm Prediction Center. And once issued, they're then picked up by the local National Weather Service forecast office. And at some point, they start shaving off the counties in the watch until it's over. Next slide. So what is SKYWARN? It's a National Weather Service program in which trained volunteers provide the NWS with timely and accurate severe weather reports. And the key focus of the program is to save lives and property. If you look down in the right-hand corner, you'll see a picture of 2 tornadoes from the Palm Sunday outbreak in April of 1965. During this outbreak, 48 tornadoes raked Wisconsin, Iowa, Illinois, Indiana, Michigan, and Ohio, resulting in 260 fatalities. And depending on what set of statistics you look at, injuries amounted to anywhere from 1,500 to 3,400 that day. Because there were 17 tornadoes rated an F4 at that time, and there were so many fatalities, the National Weather Service formed an assessment team, a service assessment team, looking at what can be changed to save more lives. The final recommendation of that report was to increase the number of trained spotters to report severe weather to the local office and to actually have a program where there's uniformity in the training. And Toledo, Ohio, NWS took this on, formed a program called Tri-State Weather Network, and it was so successful that the National Weather Service implemented this program nationwide as SKYWARN, and it is the basis for the program that we enjoy today. I want to highlight the fact that you will be spotters and not chasers. Spotters provide a report from a fixed location. It could be home, could be work. It could be in their car if they're just headed home or headed to a destination, but they're not actively chasing a storm, because in North Carolina, that's very dangerous. It's hard to see tornadoes over the tall pines that we have, and also tornadoes can be rain wrapped. You can't see long distances, so chasing is discouraged in North Carolina. Next slide. Again, Central Carolina SKYWARN serves Raleigh National Weather Service. We have 18 counties, of which Orange and Durham are a part of. If you look at the top two pictures, these are pictures of the SKYWARN station at the Raleigh National Weather Service. We have two, on the left, we have two VHF, UHF radios, and then just to the right of that station in the corner, and you see the kind of diagonal catty-cornered bookcase there, is the HF station. There are over 2,000 spotters in central North Carolina alone, and only 25% of those are hams. So most spotters are not hams, and there are over 350,000 spotters nationally. Next. So we've got a lot of sophisticated technology. So why do we even need spotters? The simple truth of the matter is a lot of technology can't detect every instance of hazardous weather. For example, we have dual pole radar, but it can't tell what exactly is happening on the ground, and that's where you come in. It can see what it thinks is a tornado, but we don't know that there's a tornado unless somebody spots it or we see a debris ball on the tornado. Hail radar is pretty good at detecting hail is going to fall. It's not very accurate or as accurate in detecting the size of the hail. If it falls and it's in your yard, you can obviously go out and measure it or liken it to an object and provide the size. So those are two instances where spotters provide ground truth information. Also, spotters can tell how the weather is actually impacting their area. If the National Weather Service thinks severe weather is occurring, but they're not getting any reports, they will often call a spotter in the database who resides in the area where the storm is and say, hey, if you look out your window, can you tell us what's happening? Spotter reports verify warnings. Again, technology can't determine every incidence of hazardous weather. So when you make your report, it lets them know were they accurate or not in issuing the warnings. They want to avoid too many false warnings because the public then is reluctant to take action to protect themselves from severe weather. Your report may help a forecaster make a warning decision. Should they continue that warning, discontinue it? If they're on the borderline trying to make that decision, if you make a report of severe weather, they may take that into account and keep the warning going downstream. And your reports add another layer of credibility to that warning, so the public is more likely to take action. Next. Okay, so what makes a thunderstorm severe? Any one of these three things: hail, 1 inch in size, that's quarter sized or larger, or wind speeds of 58 miles per hour or greater, or a tornado. Lightning does not make a thunderstorm severe, no matter how vivid, impressive, or deadly it is. Only one of the other three. Next. So once you suspect, we know what a severe thunderstorm is, we need to be aware of watches and warnings. There's a difference between the two. A watch means conditions are favorable for severe weather to develop in or around the watch area. And nothing may happen or then again, something may happen. So it means watch, just be aware, plan, prepare, be aware. If you look over at the right hand, upper right hand graphic, you'll notice this is a watch, and the watch covers a very large area. On the other hand, if we look at a warning, warnings means hazardous weather is occurrent or imminent. And so you want to take action to protect life and property. If you look on the right-hand side, you'll notice in contrast to the watch, it's a very small area. It's just the area that is impacted or likely to be impacted in the very near future, whereas watches may last 5, 6, even 10 hours. A warning usually lasts anywhere from 45 minutes to an hour. Next, please. So what will you report as a spotter? The first criteria is hail. You want to report any size hail you see, and at the conclusion of the event, please report the largest hailstone that you observe and any damage. You may see a lot of hail in your yard, and you will discover that it is not uniform in size. So you want to look for the largest hailstone and report that size. Even if it's only one piece, you report the very largest you see. To estimate the size of hail, you can compare it to well-known objects like coins or golf ball, tennis ball, baseball. Please don't liken it to a marble, because marbles are different sizes, and that can be confusing. You can also measure the hail with a ruler. That's very helpful. Next. Hail usually doesn't cause too many injuries, but it can certainly cause a lot of crop damage. Even this hail the size of peas can destroy a crop. You can see what it did to this roof here. And then if you look at the car, once you get hail that is golf ball size or larger, it can begin to damage the windshield of the car and can really eat the siding off of the house. If you have hail the size of a tennis ball, it can fall at speeds faster than 100 miles per hour, and you can imagine what that would do to a rooftop too. Okay, next slide, please. Okay, you're also going to report estimated or wind speeds of 50 miles per hour or greater. Measured is preferred. Some of you may have professional weather stations at home, like a Davis setup, and if it's measured, please report your wind speed is measured, but it's okay to estimate too. And to help you estimate, you'll see this chart over here, which is the Beaufort wind scale. And remember, you're going to report speeds of 50 miles per hour and greater. So when you start seeing damage to chimneys, I don't know that many people have TV antennas anymore, but not like they did when I grew up. But antennas, certainly, I guess ham radio antennas qualify there. Large branches, broken trees uprooted, and then removal of shingles, windows broken, trailers overturned, trees uprooted, etc. You can report those things, and the National Weather Service can then correlate that with their radar and come up with the appropriate wind speed. You will get a handout from me by email, and it will have this Beaufort wind scale on it. So you don't have to remember just from this, 30-second look at the screen. Next. Okay, you're going to report flooding or flash flooding where none normally occurs. Flooded roadways, rivers, streams, giving the approximate water depth. If you know the name of a stream or a creek that is flooding, by all means, share that. Or if it's in a park and it's flooding the park, give the name of the park. You want to report, are the floodwaters standing or flowing? Is the water rising? Is it staying steady or falling? Any cars in the floodwaters, any water rescues going on? If you look down here in the lower right, this was from Chapel Hill several years ago, and flooding going on and cars were stalled and they were getting ready to do a rescue. You don't want to report ponding. You want to on the road. When the water is over the curb, it is considered to be 6 inches deep. So report it then when it's at least 6 inches deep or over the curb of the road. If there are any roads that are closed due to flooding and you know that, please pass that information on too. Next. Okay, you want to report wild clouds, funnel clouds, and tornadoes. And the key here is rotation. And I love this little saying, if it doesn't spin, don't report it in. So you're going to be looking for rotation. And we're going to talk a little bit more about what each of these is in a minute, but the wild cloud is on your left. And then you have a funnel cloud just below that, and it's halfway down. And we'll talk about what the difference between a funnel and a tornado is in a moment. And then there's a tornado in the lower right-hand corner. The picture in the upper right-hand corner is the oldest known photo of a tornado. And if I remember correctly, that was South Dakota, yeah, 1884 in August. So I just love that picture. So I threw that in. Next. So if you report one of those things, the first question you're going to be asked is, can you tell if it's rotating? How far beneath the cloud base does a funnel cloud extend? Do you see any debris, dust, leaves, or other debris? Can you see any damage? Are there any injuries that you know of? Does it look like a piece of rope? If it does, it's a decaying tornado. Or is it V wedge shaped? It's going to be a mature tornado. What direction is it moving? Now you want to report only what you see. And if you look at that top picture, you see at least a funnel, but it's hard to tell whether it's on the ground because it comes to the tree line. And report what you see. I see a funnel. I can't tell if it's a tornado on the ground because it's beyond the tree line. And that's what the National Weather Service wants you to convey, what you actually see, not what you assume. Now, in this picture, I will say, if you see debris flying in the air, you can assume it is probably on the ground. If you're seeing shingles and siding or, you know, parts of the roof flying, you can guess it is on the ground. Okay, next. All right, you want to be aware of tornado lookalikes, and all of these are not, none of them are tornadoes. Over here, you see a top left-hand corner is a scud cloud. Scud cloud's just a fragment. It's not attached to the base of the storm, nor is it on the ground. A rain shaft in the upper right-hand corner. And from a distance, that might look like a tornado. And then on the lower left-hand side, this was actually called in as a tornado, and it's actually, there was some rotation in the cloud, but there was a fire at that location, and smoke was being pulled up into the updraft. So this was just smoke, but someone called it in as a tornado. And then over on the right-hand side was a nuclear power plant, and it's steam coming from the nuclear power plant, but from a distance. That would fool me, you know. So sometimes you have to say not far enough, not close enough to see whether there's rotation or not, but it appears it could be, you know. Could be a tornado. We can't tell, can't see the rotation, can't tell if it's on the ground. Okay, next. You always want to report any storm damage, any siding or roof damage, and try to be accurate. If it's just a few shingles off the roof, report it as such. If the whole roof is gone, you can say the whole roof is gone. If half of it is, half is gone. Any down limbs or trees, their approximate diameter. If I were looking at that right-hand, upper right-hand picture, I'd say, gosh, there's 1, 2, 3, 4, 5, 6, maybe 7 or more trees that have been snapped off, and they would range in diameter from maybe 12 inches in diameter to maybe a foot, foot and a half in diameter. On the lower left-hand picture, could you legitimately say the roof is gone? Yes. Okay, that's legitimate. The roof is gone. Part of the second story is gone as well. That would be significant damage. By the way, that was from the April 16, 2011 tornado in North Raleigh. Here's where a mobile home was flipped in Leggett, North Carolina, and this was due to downburst winds. When you first look at it, you might not even realize it's been flipped, but you can see the tie downs are at the roof level when they should be at the lower part of the mobile home. This was literally flipped and it's lost all structural integrity. Next. Okay, it's okay to report large limbs like the upper picture, okay, but don't call in the National Weather Service for small branches like you see in that picture down there, or weak or dead trees. They're looking for damage to live trees, okay? Next. Other things not to report: don't report vivid lightning or it's lightning every 2 or 3 seconds. Lightning is part and parcel of a thunderstorm, but if there's damage, if a house is struck by lightning and causes damage or a fire, you can certainly report that, or an injury. Please do not call to report personal power outages. Please call your power company. You'll get much faster service. And they can even give you an estimate of when your power will be restored. The following are comments that the National Weather Service has received, but it really doesn't tell them about the criteria we just talked about. It's raining cats and dogs. That really doesn't describe anything other than there's a heavy downpour, and that's not a criteria they're interested in receiving. It's getting dark to the northwest. It probably will get dark somewhere when a thunderstorm hits. It's really windy. That's not an estimated or measured wind speed. 2 inches of water on the road needs to be 6 inches or more. Drive carefully if they're 2 inches, hazardous. But again, wait till it gets to be 6 inches or over the curb reporting. And then certainly the one, nothing is happening here. If you call Central Carolina SKYWARN or you call the National Weather Service to report that, you're taking up time when somebody else who has a more serious report to make, such as tornado on the ground, you're delaying them from getting their report in. Okay, next. So when you make your report, you want to report what you observed. What was it? Was it hail? Was it flooding, flash flooding? Was it a tornado, a funnel cloud? What was it? And then when did it occur and how long did it occur, if you know how long? Often people who call in hail say, well, it's been hailing for 2 or 3 minutes and now it's stopping. You may or may not know the duration of a tornado on the ground, but report the time that you observed. And then you want to give your name and contact information. You want to report only what you observe and hear. And I'll give you an example. Let's say a tornado warning was issued for your county and you're safety conscious, so you go take cover like you should in a safe place in your home, and you hear what appears to be a freight train, and your house is even shaking some, and in 30 seconds, 45 seconds, it's gone. And you go outside and you look and your house is in great shape, thank goodness, but you look next door at your neighbor's and half his house is gone. Would you report you saw a tornado? No. Yay, Laurie, glad to see you. Okay, the answer is no, you didn't see it. You could report that you heard what sounded like a freight train and that your house was actually shaking. Okay, they will correlate the time of that with the radar, and once they do the survey, if there's significant damage, they may do a tornado survey and put all the information together to determine what happened. So report only what you observe and hear. And again, it's what you observe and hear, not what your work colleagues, wife's friend heard and reported. Okay. Can you report later on? Yes. It doesn't have to be immediate. It's great if it can be, but it may happen overnight when you're in bed, and when you get up the next morning, you discover a tree is across your driveway or across the road where you leave your subdivision. You can make a report the day after and say, I'm not sure what time this occurred, but it was when I went to bed the tree wasn't in my driveway when I got up this morning, it was. And the National Weather Service can again correlate the time and with radar. The National Weather Service also appreciates photos. So if you want to send a photo in, that would be great. The little photo of the hail with a quarter in someone's hand was something that someone sent in, which was great because it really did show the size of the hail. And not only does the National Weather Service appreciate them, Central Carolina SKYWARN does too. We often turn around and use those photos not only to verify warnings, but also to use for training purposes. And there are multiple ways to make your reports. If you want to make it to Central Carolina SKYWARN, the best way is to call in your report. We're on the 145-210 repeater whenever a watch or warning for either a severe thunderstorm or tornado is issued. So tornado watches and warnings, severe thunderstorm watches and warnings. We also activate for winter weather and for hurricanes as well. We do have the Central Carolina SKYWARN Facebook page. You can make a report there. We will pick it up. You may call the Raleigh National Weather Service. In the handout that you received from me, there will be a spotter number on it. It'll be at the, I think it's at the top of the page. Read both sides. Anyway, it's for trained spotters only. It's a confidential number, a private number, which should not be shared with others. It's reserved exclusively for you, for trained spotters. You can also post to the National Weather Service Facebook page. There is a severe weather report that is can be filled out on the Raleigh National Weather Service website at weather.gov. Look at the bottom and you will see one for severe weather reporting. You can send an email if you so desire to nws.raleigh@noaa.gov. That's where you would send your photos. You can tweet your report. If any of you are COCRA's folks, your COCRA's reports that you make there will automatically be picked up by the National Weather Service. And there's MPING. And if you go to the next slide, please. MPING is an app. It stands for Meteorological Phenomena Identification Near the Ground. And it was a project to collect weather information for the public. And this app you can get it from iTunes or Google Play for your smartphone or mobile device. Anyway, it was designed to improve radar interpretation, and it's been extremely successful, and they've expanded the criteria. So the researchers compare the reports that are made with what radars detect, and they develop new forecasting technologies and techniques with it. And this is a picture of it over here of the app, and basically you select your report type and it'll pick up your current location, and there are other drop-down menus so that allow you to accurately describe your report. When it's done, you can submit. You could submit up to one a minute. I wouldn't encourage you to submit one a minute, but you can do it that often. Okay, next. Okay, we activate on the 145-210 repeater whenever there is a watch or warning in any one of our 18 counties. So if there was a watch or warning just in Orange County and nowhere else, we would activate for you. And we activated other times as directed by the Raleigh NWS, such as for winter weather. If it's more than a nuisance event, we activate. If it's just a nuisance event, flurries, that kind of thing, we will not activate. You will hear us mention sometimes standby mode. That means it's a non-directed net. Others can use the repeater with us. We try to be, try to play very nice in the sandbox. And sometimes you hear active mode, which means it is a directed net. I'm always asked what happened to the 14688 repeater, and that suffered some extensive damage in a ice storm. We had 2 ice storms back to back. And so we are a temporary, I guess, user of the 145-210, which is extended now for well over a year. I think since Dorian, and will continue to do so until the 8.8 is repaired, and Danny Hampton is working on that. So one day we will go back home. Okay, next. You want to be prepared for severe weather by staying informed. One of the best ways is to have a NOAA weather radio, as pictured on the right-hand side. You have a smoke detector probably in your house to detect a fire. Well, your NOAA weather radio is your smoke detector for severe weather. North Carolina back in 2008 ranked #1 in the country for nighttime deaths due to tornadoes. And that's not a statistic where you want to be #1. And most people are pretty weather aware until they go to bed at night. And when they go to bed, there's no longer the TV with the banners running across the bottom of the screen. Their friends are probably asleep too, so no one calls to tell people, hey, you're in the path, you know, your county's under a warning. So the best way to have it is a NOAA weather radio, and I will tell you they work best if you leave them on. One lady told me one time that she didn't like to be awakened in the middle of the night, and it kind of defeats the purpose, you know, of it. But the newer ones, the newer models, you can actually program for what kind of weather events you want to be awakened for. If you're not in a flood zone and you're not interested in hearing a flood warning, you can filter those out. But I encourage everyone to have a NOAA weather radio. You can get an app for your phone, which is mobileweather.gov, which provides weather data. You can always visit the Raleigh National Weather Service website, weather.gov/RAH. Facebook page, both the Raleigh National Weather Service and Central Carolina SKYWARN try to post alerts there. Tune into your local favorite TV and radio weather forecasters. I would encourage you, particularly on social media, be careful where you get your information. Make sure it's a trusted source of information. There are a number of folks out there, there are even high school students who have quite a following, and they have no meteorology training at all and putting out information. So just be careful. You automatically get WEA alerts to your cell phones for the more severe weather events, such as a tornado. They do not alert for just severe thunderstorms, but they will alert for tornadoes. Many counties have free alerts, and of course, we read the alerts on Central Carolina SKYWARN net. Okay. All right, let's talk a little bit about storm formation. And there are 3 ingredients for a thunderstorm, and it's like making a cake. If you have all the right ingredients, you get a great cake. If you're missing something, maybe it's the yeast, maybe your cake doesn't turn out too good. Okay, with a thunderstorm, you need to have 3 ingredients. You need to have moisture, and that's to form the clouds and the precipitation, and we get most of our moisture off the Gulf of Mexico and the Atlantic Ocean. Some moisture comes from evaporation. We also need instability. Instability is a measure of the atmosphere's tendency to either enhance or deter vertical motion. And so instability means that warm air will rise and cool air will sink. So we have to have that. But you have to get something to get that warm, moist air going upwards. And usually that is something like a front. It could be a cold front, a warm front. It could be the outflow boundary from a storm. It may come from being on the side of the mountain where warmer air can be pushed up and rising. So anyway, you need some kind of lifting mechanism. A sea breeze can be a lifting mechanism too. Next slide. I know some of you have seen this. If you look at the radar, you see kind of a circle, or maybe you've seen just half of it. I'm sitting here pointing to the screen. I'm sorry, I feel like I'm on the whiteboard. Okay, Anyway, this is the outflow boundary from a storm, and this is rain-cooled air that rushes out from the storm, and it serves or acts as a mini cold front. And so when it hits the warmer air, the warm air next to it, it will rise up and cause new thunderstorms to form. Okay. Next, please. The fourth ingredient that is needed for organized severe thunderstorms is wind shear. And wind shear or vertical wind shear is a change in wind speed or direction with height. And if you look at the left-hand side of this graphic, you see a storm, you see warm air rising, and you see rain falling, and the wind shear is basically the same. So this storm is not going to live very long because the rain, the downdraft is going to overtake the updraft, and the storm will just die out. On the other hand, on the right-hand side, you can see that this is a sheared environment because the wind speed is increasing with altitude. The higher you go, the stronger the wind. So the storm looks like it's leaning. So you've got an updraft that's leaning, and then the downdraft comes down. So they're separated, and this means that the storm will likely be stronger and have a better chance for severe thunderstorm impacts. Okay, next. Okay, this is the life cycle of a thunderstorm. In the bottom picture, you see the towering, cumulus stage. This is the beginning stage, and you have an updraft, so you've got air moving up in a column. The storm begins to produce precipitation in the upper portions of the storm, and it doesn't fall to earth yet. The storm keeps rising, and we have the mature stage, and now you've got not only the updraft and the rain is falling to the ground, but you've got, that's the downdraft, but you've still got the updraft, and the cloud has reached all the way to the area where the rising air is the same temperature as the air is adjacent to, and so it stops there and kind of fans out. If you look at the dissipating stage, the downdraft is now overtaking the updraft, and what's left is an orphaned anvil. It's the remnants of an anvil where the storm has dissipated. It's lost its favorable inflow of the updrafts. And if you look at the top row of pictures, these are pictures that correspond to each of the stages in the graphics. Okay. All right, next. Okay, there are three types of thunderstorms that we're going to mention. The first one is the single cell. It is often called the pulse storms or the little popcorn storms. And you have an ordinary cell. It has one updraft, one downdraft. They're usually pretty short-lived. You get some hail or gusty wind, but they're typically not severe. You see this one over here on the left-hand side, it's a little small single-cell thunderstorm, and this is what it might look like on radar. It has a short lifespan of usually about 30 to 45 minutes. The downdraft will form within 15 to 20 minutes of the cell initiation, and then it'll begin to weaken 25 to 30 minutes. Okay, next. Okay, the next type of thunderstorm is called a multi-cell thunderstorm. And basically, this is a group of cells moving as a single unit. And each cell is at a different stage of development. If you look at the top graphic, where you see the red arrow, you see there's one that doesn't have an arrow on it, but it's going to be building on the right-hand side. It's just barely beginning to initiate here. Then there's a red arrow, and you see a storm that's a little bit further along, and then you see the main storm here. You've got an updraft and a downdraft. Anyway, all these storms move together as a group, and this is a very common type of thunderstorm, and they occasionally produce severe weather, damaging winds, hail, and could even produce an isolated tornado. And here is a actual picture of a multicellular thunderstorm at the bottom. That's one type of multi-cell thunderstorms. There's another type too. And if you will advance the screen, thank you. Squall lines. Everybody likes the squall. Well, I won't say like, we like to see them on the radar. You know, they're fascinating to watch. And basically, in the squall line, these storms, you've got 2 or 3 storms that start out and then they form a line. And they're usually oriented north-south, sometimes northeast to southwest, and they usually move either northeast, east, or southeast. And these storms, line of storms, can be over 100 miles long, and they can move as fast as 60 miles per hour. Usually there will be damaging winds, that's the main threats, but also hail, weak tornadoes, and flooding are also possible. The the highest winds when you see a squall line, if you look to the left, you'll see kind of a bow-shaped squall line. At the very apex of the bow is where the strongest winds will be in a squall line. Okay, next. Okay, the supercell. Whenever there's a supercell, someone is going to have a bad day somewhere. Less than 5% of all thunderstorms become supercells. They have a tendency to be long-lived. They can last longer than 3 hours. And so you know they have a strongly sheared environment. They always produce severe weather, and they can produce very large and violent tornadoes. Their updrafts can attain speeds of more than 100 miles per hour, and they have a highly organized and rotating updraft. Next. Okay, here's the, this tells you how the updraft forms. You've got a highly sheared environment, and what happens is the wind speeds increase in height, it gets that air in the atmosphere rolling, okay? And then you have an updraft, which lifts that horizontally rolling air up, and that forms the rotation within the updraft of the thunderstorm. Okay, next. Okay, let's take a look at a classic supercell. Here we've got a photograph of one on the right, which pretty much mirrors the graph on the left. And if you look at this, one of the first things I want to point out is the anvil. And when a thunderstorm forms, the clouds build vertically in the atmosphere until the storm's updraft, that warm rising air, reaches an equilibrium level. And that's the point where the surrounding air is the same temperature as the updraft. And this point of equilibrium is marked by the tropopause. And so rather than continuing to go up into the tropopause, it fans out. And it forms the anvil of the thunderstorm. Now, sometimes the rotating updraft is so strong that it will punch through that tropopause and create a dome above the anvil, and that's called the overshooting top, and you can see the little graphic pointing it out here. And the overshooting top is a sign that this is a severe thunderstorm for sure, and the longer it lasts, the more likely it is to be an indication of a very strong updraft. If you could follow a line down from that overshooting top, if you went down, that's where you would find the hail in the storm at your level, the ground level. Okay, in the front of the storm, you see a shelf cloud. And this is the shelf cloud is the front of the storm. And shelf clouds can develop in any type of thunderstorm, but this is what the front of the thunderstorm here. Over to the back side of the storm, southwest flank or southern flank, you're going to see a wall cloud develop. And we'll talk about wall clouds a little bit later. And if a tornado is going to form, it's going to be off that wall cloud, and then you'll see a precipitation-free rain base. Flanking lines are additional thunderstorms at different stages of development. And the main storm tower is from the base of the thunderstorm up to the anvil. Okay, so if you look over here, you can see some of those same features. Okay. The shelf cloud is associated with the downdraft, and I think we have something to explain that in just a minute in another slide. Okay, next. Okay, so when you look at that kind of configuration, these are signs of a very strong storm. Overshooting top suggests a powerful updraft and a stronger storm. So if it doesn't have the overshooting top, it's not as strong. When you see that anvil fan out, that's a sign of, especially if it has a crisp edge, that's a sign of a more powerful and active storm. If you look at the main storm tower, if you see kind of a cauliflower-like appearance and very crisp looking appearance, again, sign of a strong storm, as opposed to this soft marshmallowy looking storm tower on the right hand side. Okay, next. Okay, the shelf cloud, that's what's at the front of the storm. And people often see it and become scary, and some people think, oh, tornado. The tornado cannot form off the shelf cloud. When you see a shelf cloud, you can expect when it comes very close to you or over you, you can expect that the winds will pick up and change direction. But what's happening is you've got warm air, cold air coming down from the rain-cooled air, and that's hitting the ground, and it meets warm air, and warm air, indicated by the red arrows, is rising. And you get condensation that develops, and that forms the shelf cloud. If you looked at this, well, the graphic at the top shows the shelf cloud, and the graphic at the bottom shows a line of storms. What first hits you is that shelf cloud, and that's what it would look like on radar. Okay. Next. Thank you. Here are some great examples of shelf clouds. The one on the top left was taken by a spotter in Granville County, and you can see it looks very turbulent underneath. On the right-hand side, you can almost see some striations in that cloud, and it almost looks like little fingers pointing down. Here are some others, and you can see variations in how they look. They can look very foreboding and scary, and this is what you see when you are in front of the storm. And again, you can expect the wind to pick up and the temperature noticeably cooler. If you think back when the storm has come over you, you've probably encountered those conditions. Okay. And the shelf cloud is associated with a downdraft. Okay, next. Okay, so it marks the leading edge of the gust front. It's produced by rain-cooled air. It's usually in an area of low shear, and it slopes away from the precipitation. The precipitation is going to be behind it. It hasn't gotten to you yet, and it can be associated with a squall line and damaging straight line winds. Okay, next. Okay, the wall cloud is on the southwest flank of the storm, and what's happening is it's a lowering of the base of the storm. You've got warm, moist air feeding the storm. It's the updraft, but it also pulls in some of the rain-cooled air around it, and when it does, it causes condensation, and that forms the wall cloud. The longer the wall cloud persists, the more likely it is to develop a tornado. And you're looking for rotation in this cloud too. You're looking for rotation within the wall cloud. It's not real rapid. It's fairly slow, but it is obvious that it is rotating. And these are pictures of different types of wall clouds. The rain and the hail will occur probably before the wall cloud, but then again, sometimes wall clouds are there and there's a tornado and it can be rain wrapped. Okay, next. Here's a tornadic wall cloud. Now, I'd be pretty frightened if I saw that one. I'd be headed for the basement or somewhere safe. You want to look for 4 things. Will my wall cloud produce a tornado? Needs to have all 4 of these things occurring. Is it rotating? Does it have rapid vertical motion such you can see other scud clouds, bits and pieces of clouds being pulled up into the updraft? Are there strong winds blowing into the storm? And does it persist? The longer it persists, the more likely, 10 minutes or more. So those are the 4 things you want to look for. Okay, next. Okay, from the wall cloud, a funnel cloud may develop. A funnel cloud is basically a rotating column of air attached to the base of the storm, but not yet on the ground. And you want, hopefully you can tell whether it is rotating. A lot of times it's kind of smooth looking from the rotation. If it's real raggedy in appearance, you're gonna, if you can watch it from a safe distance, do so to see. But the smoother it is, more likely to indicate that it is a funnel cloud. There is again, they're not on the ground yet, but there is kind of the halfway rule. Once you see a funnel cloud get halfway to a third of the way down, there is a chance it could be on the ground, but the condensation funnel is transparent at this point. Once it kicks up debris, you will see that the condensation funnel turns darker, and you can actually tell it's on the ground. So you want to look for debris. If you're not seeing debris, it's not on the ground yet. Okay, next. Okay, the mature tornado is upright, and these are examples. You've got kind of a wedge-shaped tornado in the upper left and a V-shaped tornado, very similar in the bottom picture. And here's a rain-wrapped tornado in the upper right-hand side. Tornado, violently rotating column of air attached to the base of the thunderstorm cloud and on the ground. So funnel not on the ground, tornado on the ground. Okay, next. Okay, at some point, the tornado will lose its warm, moist fuel, the updraft, and when it does, it begins to lean over, to thin out, to become more rope-like or snake-like. Nevertheless, it is still very dangerous on the ground and can cause extensive damage. But these are in the late stages of a tornado and signify that the tornado is beginning to die. Okay. Next. Okay. Now, just as damaging as tornadoes are straight line winds, which are non-tornadic, non-rotating winds, and this is some damage caused by straight line winds, particularly microburst. The one on the right was from microburst at RDU International Airport, and the other is in one of our counties. The straight line winds actually took the roof off of a house. Our prime months for non-tornadic winds, as you can see in the graph below, are May, June, July, and August. So we're entering that time period now. Most of the wind damage that you see done by severe thunderstorms is caused by a downburst, and downburst winds can exceed 100 miles per hour and cause damage that looks very similar to tornadoes. Okay, next. And here's some information about thunderstorm downbursts. We've got some pictures of one. You can see the air, these are damaging winds descending from the base of the thunderstorm. It is thought that rain is falling. It hits an area of a dry layer of air. Evaporation occurs, and so the air then becomes cooler and more dense and plunges to the ground. And it's in these pictures, and this is bringing down moisture and rain with it. So you can see what happens when it hits the surface of the earth, it spreads out. So if you're driving in a distance and see that kind of situation where it looks like it has this rain foot where it's spreading out, you can guess you have just observed a microburst. Okay. All right, let's talk about safety. as we said, hail doesn't usually cause deaths. There are very few fatalities, but there can be injuries. So you just use common sense, get inside. If you can't get inside, if you're close to your vehicle, get in a vehicle and remain there until it is safe. Don't try to run through it. Okay. Next. Flash flooding, number one thunderstorm related killer. Flash floods cause more than 90 fatalities each year. More than half of all flood related drownings occur when someone drove a vehicle into flood water. 6 inches of more moving water can throw you off your feet, knock you off your feet, and 18 to 24 inches of water can actually move most vehicles, including SUVs and buses. So 3 simple rules: get to higher grounds. If you see flooded roadways, turn around, don't drown, take a different route, and then stay informed, be alert as to what is occurring. Next. Tornado safety. So for this, when a tornado warning is issued, you want to go, if you have a basement, go to the lowest level of your house. If that's the basement, that's where you're the safest. If not, in your ground level, try to put as many walls between you and the exterior of your house as you can. Try not to be in a room that has an exterior walls. Try not to be in a room that has windows. And the top floors definitely do not protect you. Mobile homes are not safe. Find an alternate shelter if you can. Maybe you have a neighbor nearby and have an agreement when a warning is issued that you can go stay with them. Okay, next. And then damaging non-tornadic winds like the microburst. In any severe thunderstorm, the best thing to do is follow the same safety rules for a tornado if there's a severe thunderstorm. And at different wind speeds, you can see the damage that can be caused. And if you look at 50 miles per hour, you see large branches. 60 to 70 miles per hour can damage buildings, cause structural damage, peel back here it's peeled back the tin of a roof, and at greater than 70 miles per hour, you can have significant property damage. So follow the same safety rules there as if it were a tornado. Okay. Next, lightning. Very dangerous, and most deaths or most injuries occur when people could see that it was thundering and lightning, but didn't allow enough time to get to a safe location. They wanted to continue maybe one more hole of golf, or one more of something, and they were struck on their way to safety. And as you can guess, in North Carolina, recreational fatalities are more common because we have lots of places to fish, lots of places to play golf, that kind of thing. And there are lots of outdoor, unfortunately, opportunities for that to occur when a severe thunderstorm happens, or even a regular thunderstorm, not even severe. So anytime you hear thunder, go inside, or you see lightning. You want to find a sturdy house, building a car with a roof, not a convertible. A cloth roof is not safe. Stay indoors for at least 30 minutes until you last heard thunder. The reason for that is lightning can travel 15 to 20 miles away from its parent storm. In fact, it can look sunny and lightning can still strike 15 to 20 miles away when there doesn't appear to be a cloud in the sky. So you want to wait at least 30 minutes before you go back outside. Don't retreat to dugout sheds, pavilions, picnic shelters, gazebos, tents, etc. They are not safe. Don't use electronics outlets, corded phones, or stand near windows inside your house. Cell phones are safe, but corded phones are not, and people have actually been suffered injuries, sustained injuries. Don't take a shower during a thunderstorm. It's possible for to be struck by lightning in that way. Avoid washing dishes. Don't stand under or go near a tall tree if you're outside. Don't swim. Try again. There's really no place that's safe outside, so try to find a safe shelter if you can. Okay. All right, I want to invite all of you to join us on the SKYWARN Information Net. It's every Tuesday night, 9:15 p.m. on the 145-210. Repeater, we have a weekly weather impact briefing that is provided by the National Weather Service, and we hear most often from Nick Petro, warning coordination meteorologist for the Raleigh National Weather Service. He was WX3H, still is, and he was a ham radio operator even before he was a meteorologist. And the other person who often does the briefing for us is Brandon Dunstan. He's a meteorologist there too, and he also is a ham. So you will hear the weekly weather impact briefing. It's great, particularly when we're expecting severe weather, because you get a lot of detailed information and have the opportunity to ask them questions. To access the briefings each week, they do a briefing specifically for us. If you go to the Central Carolina SKYWARN website and look across the main menu, you will see one that says weather briefing. You click on that and you can see what the warning coordination meteorologist is going to be discussing. Okay, next. We have a Facebook page, and we would love for you to like us on the Facebook page and occasionally read it. You'll find interesting information there, and we place the warnings and the watches there as well. Next. Okay. I told you there would be a little bit of, or Lori told you that she was going to be sending me a piece of paper. She will send me a list of the check-ins tonight with email addresses. I will email you a SKYWARN spotter handout, which has all this information that we've talked about tonight. A list of what to report. It'll have the confidential telephone number, which you can call to make reports. It'll have a link to, this is most important, one of the most important ones. There's a link to register online to be included in the National Weather Service database. So go to that link and register. Okay, that way you'll be put into the database. There's also a link for you to print out a SKYWARN certificate with your name and date for this training. Your training is good for 3 years, at which time you'll want to renew your training. You can do it at the end of 3 years or even before if you so desire. And I will say that all of our activations are live streamed over www.broadcastify.com. So if you're at work or wherever and you're not close to your ham radio, but you have your computer up, you can go to broadcastify.com, Wake County, and look up Central Carolina SKYWARN and listen to us that way and hear what's being reported. Okay, I think that, Bruce, if you'll go one more screen, I think that concludes our...
That's it. That's the last one.
Thank you. Okay, so that's it. You are now considered SKYWARN ready. You have been trained.
Virginia, thank you very much for this. If there are any questions, what I would suggest is people to send them in on chat rather than try to get 20 people talking at the same time. And Lori or I can go through them. I've got one right now from Bill. Bill Creary. It said, how many times does the tornado come up at nighttime? If there's a number on that, Virginia.
I do not have a number, Bill. I wish I did. I can tell you that most of the time, the prime hours for tornadoes are anywhere from around afternoon hours to early evening. And after the sun sets, conditions begin to become more stable. However, with that being said, our strongest tornadoes in North Carolina, the EF4s, have all occurred at nighttime, and around anywhere from 11 p.m. to 1 or 2 p.m. And again, that's when people are in bed, and if they didn't have a NOAA weather radio or someone to call them, you know, they were at greater risk.
Okay, thank you. I've got another question from Wilson. Is the SKYWARN repeater 14521 on Echolink?
It's 145-210,
For 210,
and to my knowledge, it is not on Echolink. I'd have to look that one up. I don't think it is. I'm pretty sure it's not. It's a Danny Hampton, a K4ITL repeater, and I don't think he has any Echolink repeaters.
Okay, thank you. One from Fred, KN4QBZ. What is a 50% chance of rain?
Oh my goodness. It's I'm going to have to send you the definition on that one. It has to do with the chance of rain occurring within something like a 25-mile radius. It takes into account the chance of precipitation and the area of which that covers. So it's really, it sounds like more than it is. It might include, say Lori and I live 10 miles apart. I might get the rain, she might not, but we both still had 50% chance of rain. And as far as the National Weather Service is concerned, it met the criteria for the 50% chance. So I will send you the official definition because I can't quote it off the top of my head, Fred.
Okay, and actually, if you send it to us, we'll distribute all of anything you might send out.
I'd be happy to send that to you.
Okay.
Okay.
I've got one from Bob, W4FK. Bob took the training at RARS Fest, so he enjoyed the review very much. So thank you, Virginia.
Thank you.
Here's an interesting one from Kathy, KN4JYP. Does the training apply across SKYWARN areas? She lives in the Triad SKYWARN area.
Yes, it will cover you, Kathy. If you live in the Triad area, no problem.
Right, very good. Any other questions from anybody tonight? Okay. I kind of have a question here. I had the SKYWARN radio on during the last storm that was coming in, and as the storm got closer, I shut it all off because it goes to a tower, and I want to make sure I don't get hit and blow up the radio. So I kind of end up in this wanting to hear but can't participate. So I've got to work this into an inside antenna that we can use. So that's probably not so much a question as is a suggestion for people that have their outside antennas to come up with plan B if they want to stay on the air.
And Bruce, that's what I do as well, is I have an outdoor antenna and an indoor one. And although my outdoor one is grounded, I switched to the indoor one.
Yep. I can hit the 145.210 a lot better than I can the 14688. So maybe I can hit that with an indoor.
The 14688, just so you know right now, the reason why is when it was on the tower, it was up, I can't remember, it's either 1,200 or 1,600 feet. And the current 14688 at its temporary location is only 350 feet high. So from where you live in Orange County, I'm not surprised.
Very good. Thank you. Thank you. And here's another thank you for you from JR and for JQR.
Thank you.
He just jumped off the page. Thanks, Virginia, from an old SKYWARN guy, JR. And here's one from Aurora. Interesting talk. I also got my husband to sit through an OCRA meeting. He loves weather stuff. We both enjoyed it. Well done, Aurora.
Very good. Glad to hear it.
And from Dan, KR4UB 162.550, NWS weather radio transmitter is on the WUNC tower. So that's a statement to everybody. And actually, that is very strong here, Dan. 162.550, obviously.
I will tell you that is one other thing that could be considered reportable. If ever you notice that your NOAA transmitter has degraded audio, has become distorted in some way, or very difficult, you're no longer receiving it at the same strength, let us know and we'll report that to the National Weather Service too for you.
Okay. And here's one from Joe Horvath, N4JHH. I'm already a registered spotter, but wanted to take some local training. Thank you very much for your time.
Yay, Joe.
Joe, thank you for attending. Really appreciate it. Any other questions? Oh, here's one from Wilson again. Remember that many 2-meter mobiles will go to 162 weather. True statement. Anything else on chat here? Okay, wait a minute. No, there's a thanks from Wilson.
Thank
Very
you,
welcome.
Wilson.
And I'd like to thank everybody for attending the SKYWARN tonight. And Virginia, thanks again for pulling this together. It was fantastic. And thanks for bringing the presentation down a little bit shorter. I think you did a super job. So.
Thank you for having me. I thoroughly enjoyed it, and we'll look forward to all of your spotter reports. And we hope y'all will enjoy join us sometime on the Tuesday night SKYWARN Net.
Okay, very good. I'm going to stop sharing now, and Lori will probably stop the recording. And